Hello, ladies and gentlemen. Today we're going to take a look at some geometry vocabulary. We're going to start our geometry adventure here with a little bit of a basic understanding of what are some basic terms that we're going to see, as well as some notation that we're going to see. For this, you're going to need those word charts that you got in class. We're going to make a little foldable to put into your notes, as well as something to write with. And eventually, like I said, we're going to put those charts into your notebook here. So as we do our work today, or as you watch this video, make sure you write down the definition, and you need to draw a picture to represent each one. So your outside of your page is going to look something like this, but then as you lift each of those flaps, you'll have two blank spaces. Probably one would be good for the definition, and maybe the other one would be a great place to draw a picture and write the symbol, okay? So let's go ahead and get started. First, we're going to be talking about a point. A point is an exact location in space. It is illustrated by using a capital letter on diagrams. Oftentimes there'll be a small little dot there, like you see here with a little dot and then an A. You graphed a lot of points in Algebra 1 when you graphed the point 2, 3 on a coordinate plane. You placed a dot there. That's what we're talking about. A point is an exact location in space, one spot, if you will. Now, points are often going to be drawn on lines. So what's a line? A line is a straight path that extends forever in each direction. You see here in this picture that I have a line drawn and there are 2 points on it, A and B. A is in that exact location, B is in that exact location. Just because those are the only 2 points labeled on here, however, doesn't mean there aren't any points that we could continue to find on this line. In fact, this line technically has an infinite number of points on it. Because it goes on and on forever, if a person wanted to place points on a line, they could do so, basically forever, right? Because lines go on and on forever. So just because you only see 1 or 2 points drawn on a line doesn't mean those are the only ones that technically could be drawn there. Many more could be placed there. When you draw a line, it's very important that you make sure that the arrows are on there because lines go on forever, whereas segments do not. So we'll see that in a minute here. And if you want to write the symbol for a line, the symbol for a line is a little mini picture of a line with 2 points that are on the line. So for example, this one I would call line AB. A and B with a little line drawn above them for that symbol. Don't put every point that's on the line, just 2 points on the line and the little mini line symbol above it. Okay? Now also one of the big ideas in geometry is this idea of a plane. A plane is a flat surface that extends forever outward. So it's like the biggest piece of paper you can imagine, if you will. Like if the paper is flat, but it continues to grow outwards, 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 and spreads outwards forever, that would be what a plane is like. Now on a plane you can draw lots of geometric things like lines and rays and points. So you could name a plane or refer to the plane by the points that are on it, by 3 points that are on it. Or you see up in the little right-hand corner up here, there's a little M. That guy right there can also be used to name the plane. So this one I would call plane ABC because it has those 3 points on it, or I could call it plane M because of that little M in the corner. Notice that little M does not have a dot there, so it is not a point. It is naming the plane itself, naming that flat surface. He's also in italics, so that's kind of a clue that he's different than the other letters in this diagram that are labeling points. So we've gone through 3 basic terms here, point, line, and plane. And now from that, let's continue to build. Line segments, guys, are just a piece of a line consisting of 2 endpoints and all the points in between. So in this picture, I have a picture of segment AB. Notice that A and B are endpoints. That's what makes it a segment. It does not go on and on forever. And the symbol for that is the A and the B again, but without the little line and his arrows. Notice there's just a little mini picture of a segment bar above it. So when we talk about segments, these are things that do not go on and on forever. It's just a particular piece of a line that has these 2 endpoints labeled, and then if I had any points in between here, like maybe an M or an M or a Q or a P or whatever, if they were in between here, those would also be on my segment, but I would still call it segment AB because A and B are the endpoints. Okay, also let's talk about array. Array is a line segment that extends forever in one direction. So you can still see segment AB here. Here's one end, here's another, but notice how on this side there's an arrow. This now makes it array. It's saying the array starts at A and goes through B forever in that direction. When we label it with a symbol, we always start with the end point first. So this would be the symbol for array AB. A is the endpoint and it goes through B. Contrast that with this one, guys, where B becomes the endpoint and the ray goes through A. This would be considered ray B through A. Notice the little arrow symbol up here does not point the other direction just because the ray is pointing to the left. Okay? The ray arrow always points to the right no matter which way the ray is really drawn in a diagram. But the fact that the B comes before the A here tells me that B is the end point and it passes through A. Now let's talk about distance and length. Now in this picture, we have AB is the segment bar, right? Notice the little segment above. And sometimes kids will say to me, Kincaid, is that a big deal? I mean, you know it's AB with a segment because you can see it. Do I really have to put that little line above it? Yes. This is referring to a segment. When you lose the little line, distance or length, you guys, is the measurement between 2 points. And the way that's noted is AB without the little bar above it. So the distance is AB as listed here, whereas this one is referring to the segment itself in a diagram. So if I said find segment AB, you might highlight that. But if I said find AB, you would then be asked to measure it to actually find the distance between the 2 points. Interesting in that notation, but that's what makes that really important, that you actually draw the symbols when you're referring to a diagram part versus if you don't, you're referring to a length or a measurement. So midpoint, guys, midpoint is just what it sounds like. It's the point in the middle, right? So if I have a segment AB like you saw there, if I found the middle and maybe I said that was D and labeled it like so in the diagram. Midpoint is the middle of that segment. So when we find the middle, we'd be saying that AD, this length, is equal to DB, this length. We're saying that that is, in fact, the middle. Equidistant means at equal distances, just the way it sounds. Equidistant means we have equal distances. And last but not least, on our little foldable guy for today, this is a big deal, guys. We see this word often throughout the entire year. The idea of what it means to be congruent. Congruent in geometry means to have the same measure, whether it's inches for segments or degrees for angles. Congruent means to have the exact same measures, okay? So when we talk about segments, this would be a good picture to get in there. We're talking about this kind of notation. This is a segment A to C that was broken apart into 2 littler segments, A, B, and B, C. Now it says below that segment AB is congruent to segment BC. And now remember, when we don't put those little symbols above, when we don't put the little segments, now we're talking about length. Length AB is equal to length BC. Congruent segments have equal length. That's what it means to be congruent. Now on a diagram, see these little red like hash marks, if you will? They're like little tally looking things. These little marks right here mean that they are marked to be congruent. It may not say 7 inches above each of them, but this piece corresponds with this piece here in our diagram, and since they have the same mark on their segments, that means that they are meant to be congruent. And if they are congruent, that means they have the same measure. Okay, so segments can be congruent to each other, but lengths are the things that are equal. So we don't say that segments are equal to each other, we say that their lengths are, but the segments themselves are congruent. Now we can do the same thing with angles. Here's an angle picture. We have some angles here. We have a bigger angle and then two little smaller ones. Notice how there's little slash marks through the angle here. Both of them are one little curved slash mark through. That means that the angles are meant to be congruent. Even though this little red one looks longer than this guy, it's not about the length of them. It's how many little slash marks you see through there. So again, in the diagram, and this part would be important to get into my notes, that angle JKL is congruent to angle LKM, and that means that their measure of angle JKL is equal to the measure of angle LKM. Okay, those little M's in front of the angle stuff, that stands for measure. So the angles are congruent because their measurements are equal. And congruent means to have the same measure. We're going to talk more about angles and the angle notation in the next video and in our next little foldable, but this idea of what it means to be equal, congruent, midpoint, all of those sort of things go together as we look at these basic geometry diagrams, okay? So I want to thank you guys for taking good notes today and getting those things into your foldable. We're going to glue that one in, and we're going to add another one to it with some more vocabulary terms that we're going to see here at the beginning of the year. Thanks again, guys. Kincaid out.